Hello, this is Mr. Stansbury. I'm going to take you through the notes on Pythagorean Theorem. At the end of this, you should be able to say, I can apply the Pythagorean Theorem to find missing sides of a right triangle, and I can use the converse of the Pythagorean Theorem to determine triangle properties. First things first, what is the Pythagorean Theorem? Okay. In a right triangle, such as this over here, we know that if we take the leg lengths, and we square them, add them together, it will equal the square of the length of the hypotenuse. Okay, so just so that you remember, on a right triangle, the hypotenuse is always across from the right angle, and it's always the longest side. And I've seen some people do this. They use this as a little arrow, the little thing here, and it points to the hypotenuse. You don't have to do that, but just kind of to help out. That's the hypotenuse. And then the two sides that make up the right angle, so this side connected to this side make our right angle, those two are called the legs. Okay, so let's take a look at putting this into some practice here. So if we have this right triangle here, we're going to use our Pythagorean theorem, a squared plus b squared to equal c squared. Okay, so the a and the b, as long as it's the two legs, it doesn't matter which one goes where. So we can put this as, say, 11 squared plus 7 squared equals c squared, or we could put it as 7 squared plus 11 squared equals c squared. Doesn't matter. Only one that we really want to make sure that we get in the right spot is the c. The hypotenuse always has to be the c squared. Okay, so let's calculate this out and see what we come up with. Okay, so let's take 11 squared plus 7 squared, and that gives us 170. So we get 170 equals c squared. So what we got to do to find c is we have to square root both sides here to get c all by itself. So c is going to be the square root of 170. So to do that, we do second square root, and you can either enter in the 170 again, or I like to do this second answer. We'll put the previous number that we just came up with in there, and it says the square root of 170, which is not terribly helpful, but we turn it into a decimal and we get 13.0384. Usually you want to round these at least to the nearest hundredth. Sometimes they'll ask you to go to the thousandth. So right now let's just go to the hundredth. So we'll do 13.0. This 8 tells the 3 to get bigger, so it's 13.04. So c is the square root of 170, or c equals 13.0.04. Okay, so either one of those would work just fine for that. 13.04, yep. Okay, b, similar idea, but look, let's see here. We have, this is the leg, and we're looking for the other leg, and we have the hypotenuse. So again, we'll always start with a squared plus b squared equals c squared. Important part is to get the hypotenuse in on the c squared, and that is the 31 is the hypotenuse, so that's going to go there. So we do 31 squared, and then again 15 can be the a or 15 can be the b. It doesn't really matter. What we're doing is we're looking for this up here, just like we're looking for this up here. I call that c. Okay, so this will be a or b, whatever we want to call it. Let's call it a. So say a squared plus b is 15 squared equals 31. So now we get a squared plus, now let's see if we calculate that out. We get 15 squared is 225, right? So 225 equals, and then we've got 31 squared, which gives us 961. So now we want to solve for a squared. So what we've got to do is we got to get the a by itself. So we now have to subtract 225 from both sides, right? And we get a squared is going to equal 961 minus 225. So we already have 961 in there, so I'm going to just push subtract 225, and that gives us 736. Right, so now we know we are going to square root those. So square root both sides to get a by itself. So we know that a is going to be the square root of 736. Or if we simplify that, second square root of our answer gives us They've reduced it to 4 root 46. Again, I'd rather have a decimal answer, 21.129. 9 tells the 2 to get bigger, so 27.13. Okay? Okay, before we continue, let's take a little comedy break.
I went back in, I had to go down to the lobby. I got in the elevator, and there were other people in the elevator with me, and I pressed the lobby. You always expect to go right to your floor, but you ever get out like too quick where you just... And now you're too embarrassed to go back, so you're like, yeah, no, this is what I wanted. Yep, I'm good. The people on the elevator know you screwed up. They're like, sure you don't want to get back on? No, I need the basement. I got to check the pipes. I'm the pipe checker here at the hotel. We're good. You guys go. I'll see you in the lobby in a minute. And you walk over back there and you press the button again, but it's too soon, so the same people are in the elevator when it opens up.
All right. Let's take a look at this. There's also something called the converse of the Pythagorean theorem. And that states if you have 3 sides of a triangle, we can figure out what kind of triangle it is. So if given 3 sides of a triangle and a squared plus b squared equals c squared, then we know that it has to be a right triangle, because that's what we were just using up here, right? If we have a right angle, and we know that a squared plus b squared equals c squared. So if we have our 3 sides, a squared plus b squared equals c squared, that has to be a right triangle. We will then know if we have a squared plus b squared, and that's bigger than the c squared, then that means it has to be an acute triangle. Okay, and then also if we have a squared plus b squared, if those two added together are less than c squared, then we know that it has to be an obtuse triangle. Okay, so let's take a look at some examples to help that idea. Okay, so here we go. We've got determine if each set of measures can be the measures of the sides of a triangle, first off. If so, classify the triangle as acute, obtuse, or right. Okay, so first things first, we got to figure out if this can even make a triangle. So if we look at this, we've got short side, basically we got the long side here. That's the important part. That's the hypotenuse, right? And then these two should be the legs of the 2 shorter sides will be the legs of the triangle. So what we have to do is figure out, do these add up to even make a triangle? So here's what I'd like for us to take a look at. Okay, so this here is a number line, and it's actually of length 11. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sections long, right? So if we put, say, the 4 right here, so we'll start 4, and we go 1, 2, 3, 4 over right there. That's 1. And if we put 6, say, starting from the other side, 1, 2, 3, 4, 5, 6. You'll notice these 2 sides don't even meet. So this cannot even make a triangle. So basically what this looks like is here's our side of 11. And then we've got our side of 4. And then we got our side of 6 here. And these 2, there's no way to make these things meet because they're too short. So we know that these 2 sides have to add up to be more than this side to even make a triangle. Okay? If it were equal, if let's say this was 5 and 6, that would be 5 and 6 would equal 11. Then what it would do is just make a straight line here of 11, and then the 5 and the 6 would make another straight line right on top of it, so it still wouldn't even make a triangle. So we know that the 2 shorter sides have to add up to be more than the longest side. So this one is not a triangle at all. Okay? B. 6 plus 10 is 16, and that's more than 12, so this can make a triangle. So it's going to either be acute, obtuse, or right. So what we have to do is figure that out. So what we're going to want to do is do a squared plus b squared equals c squared. The longest side here is always going to be the c, right? And then we have 6 and 10 here. So we'll do 6 squared plus 10 squared and see how that relates to the 12 squared. See if it's equal to, greater than, or less than. Okay, so let's calculate that out. We've got 6 squared plus 10 squared, and that gives us, oops, that's just 6 plus 10, so 6 squared plus 10 squared gives us 136. Okay, and we know that 12 squared is 144. So we know that this is less than 144. So really what we've got is this hypotenuse is actually too long. It's actually longer than what it needs to be to make a right angle. So really kind of think of it as almost like coming all the way out to here. And so then now it's going to make this here an obtuse triangle. So if the hypotenuse squared is bigger than the other two squared, hypotenuse is bigger than the other two squared, it's going to make an obtuse triangle. So obtuse triangle because of this, because a squared plus b squared is greater than, sorry, a squared plus b squared is less than c squared. Okay, we can do the same thing with these here. So let's do 3 squared plus 4 squared and see how that relates to 5 squared. Okay, so let's see, 3 squared is 9 plus 16. We know that 5 squared is 25. 9 plus 16 happens to equal 25, so 25 equals 25. So that means, up here, that means that has made us a perfect right triangle, because a squared plus b squared equals c squared. It is a right triangle, okay? And we know that that's a right triangle because, again, a squared plus b squared equals c squared. All right, and then on this last one here, 5 squared plus 7 squared, how does that relate to 8 squared? So that's 25 plus 49, and that's 64. So we've got, let's see, what is that, 74. So we know that this 74 is greater than 64. So again, if we look at this on a right triangle, okay, so we know that this side plus this side equals 74, but now this hypotenuse here is actually now too short, so it only goes up to, say, about right here. So then it's going to come in there, and that's going to, if these were straight, that would make us a nice little acute triangle. This would not be right, it's too short. So this here is going to be an acute triangle, and the reason why is because a squared plus b squared is greater than c squared, just like we have up here. Okay? All right, that's all there is for Pythagorean theorem. If you have any further questions, please feel free to ask in class. Thanks.